get more good. Okay, the grade will be good. Okay. But in fact, if I think some is a university degree, 大学部。
大学部，因为他是大学
Good. So you can write down English, no problem. Good. Okay. So everybody also can check this one version will be upgrade to new version, but I think it's almost the same. We can choose the web EDM part. Okay. Okay. In the beginning, the MIM technology is from USA. 1972, the USA, its professor is Raymond, the other is German, two men. Okay, the German is from Germany. So the Europe, I think they do this one very quickly, 1974. Okay, so Europe and America is the same step to develop this technology. But in Germany, it's very special for BASF. Because BASF is a special chemical company, they can do a lot of product and their research is very quickly. So Europe is a good among this technology. Okay. We call this one net shape process. What is net shape process? A net shape process means after you first machining, you gather the final parts. No need post-process. But in fact, most of the parts is near net shape. That means you need a second process. Then you can gather the final dimension, gather the final appearance, or gather something. So, net, very important. 反差在哪里？
等一下。
好。Okay. You should be understanding the product, including the three rules. First one, C is color. Okay, same method. But you got the drawing, the 2D drawing, the AutoCAD, CAD drawing. Okay, you can gather the 2D. Okay, you can gather the 3D model. But 3D model without any notes. Am I right? You cannot write down any text and the requirement in the 3D drawing. Because if you open the 3D model, it's just a model. But 2D can write down a lot of requirements. So one product design should be including C and F. Okay. In here, everybody is materials. So we learning materials is easier to understand. But how do you control the appearance? This problem is color. What kind of color depend on customer requirement? Depend on customer favor. For example, what's this color? This one is maple. What's this one? Oh, this one, glow. Yeah, everybody glow. How to measure the glow degree? great automation. So you need a number. Why we need a number? Because we need to computer control. We need to make a define. So color is very different to define. So you need to write up, for example, Pantone numbers, okay, or something numbers, all golden samples. Please, customer requirement for you, then you just tell them, okay? If you want to expansion this one, please give me the standard. It's very simple. So in 2D drawing, you can write down text and follow standards, which one? ISO, EPMA or something. Okay, so remember, C and F, everything should be defined by standard. Okay, don't just say, oh, yellow. My God, what is yellow? Oh, blue. No, I'm sorry. Please give me the Pantone color. Please give me golden sample. So we call this one as limitation samples. Limitation samples. You give me the limitation samples. I follow this one, and this one is a middle, high, and low. So 1, 2, 3. At least we give me a range, a window, not only yellow, but only gold. Okay, remember. So C and F and material solution follow the ISO. For example, 316L is stainless. Okay, so a lot of different materials. Okay, we know stainless as 2000 series. Now we know this one is 304, 31. 3134, 316. We know this one is 304. L is low carbon. We know this one is 310. N is no local. It's NB inside. We know 316L. Okay, and blah blah blah. A lot of something. Okay, so this is 200. 210, 201, okay, 202, and we saw this one is 400 series. It's 200, 4020 J2, 4 C. Okay, we have ABC. Which one? You should confirm, define. Okay, so this is materials. Okay, define. And the finish, what's finish? What's finish? Color different. Different. Let's go. No, I don't know. You just define. So how to make this color? Depend on custom requirement, and you define the process, fix the finished appearance. So this one is finished processes depend on process. If you do different process, the appearance is different. For example, you know the center plastic. Set plastic， set 这个啥子 ？set plastic， 很啥？啊 ，set plastic。Okay, set plastic is a user airflow within the set. When you dirty hands, you just will clean, but sometimes you will hurt because of the particles very small. Very quickly, very speed, you maybe will hurt. but the materials will be shiny. Okay, so a lot of finished products. For example, we can use the grinding. We use the hair line. For example, this is aluminum extrusion. After extrusion, we use the hair line. So you can use this one, the straight line, shiny, it's good, and the wasting amortization. Amortization. Okay, so I said the MIM is a combination process. You need to understand many mechanical process. This is finished. So C and F. In normally, relaying is a materials, and the relaying the process, but the color is different to make the change. Yeah, so you need the other company, the other partner in company, they make the color. Then it's a professional making color. So Dr. Q is was do this job many years, about 20 years ago. Every day discussing the color, discussing the glossy, okay, different glossy, okay, glosses, forms of the glosses with different how to make the surface, like the hairline, like the surface or something. We need a painting, we need a PVD. You know what is PVD? Physical vapor decomposition, dispersion. Okay, but this is coating technology, changing the different color. For example, this is gold. This is gold color. We can use plating,电镀. We can use also use PVD, 叫做真空建镀、真空布. So difference. So many processes can approach one item and the customer to say, okay, we define this one, so we need talking about the C, talking about the N, talking about the A. Okay. So this is very important in the future. If graduate from NTUSD, okay, then you go to the work, go to the job. You got the job, everybody will discuss this one every day. I promise, every day. And if you go into the Apple every year, approve vendor list, you become an Apple vendor. You need a discussion this one from 12 to 12. 24 hours. Yeah, because in Cupertino, American Cupertino, in the morning, say, oh, let's talking about next morning. It means it's 9 o'clock of Cupertino. In Taiwan, it's 12 o'clock. And discussion until 2 hours, about 9 p.m., about a.m., 2 o'clock. He just 11 o'clock. He just say, okay, let me check after lunch. Then after lunch is morning, 5 o'clock. Finish. He just said, okay. When I offer the job, I just check again. In the morning, 11. You cannot sleep, so you need to spend a lot of time. So if your English is good, your everything is good, please you become the Apple people. Buy from your classmate. Requirement. Hey, what time? We check it. So Apple people also is the same. 24 hours. Wow, listen, when you go there, you read the Bible, you collect people, many people inside. International. Everybody wants to go down, go up. Okay. So this is a triangle, When you in the bottom, so many people. When you're top, so next transfer. The top is a team cook. Team also here. If you can charge the team. Or team charge. In here, the triangle top is a team. You can try again. You can shoot. He can share everything for you. But you should be learning. Then you can from base and go up, go up. Okay, this is rule. Okay, very starting very hard, very hard. Okay, everyone. Okay, so this is a lot of member group educations. Okay, totally about Europe is 17 company, just 17. That's a quarter of China. In China, including China with Taiwan, Hong Kong, Macau, 4 areas. Totally about 300 companies of NIM. So in Asia, about 400 companies. So this is small group, but the technology is good. Okay, so there's some additive and result we share here, and at the same time they are promote the technology. Why? Because this one is a technology we can many people inside, and they can make the money for many young people. So everybody has a choice in this area. Okay. Okay, please. I think we just make an examination by this one major. This one is a major. Okay. It's easier to understand. Everybody can do it. Okay. In Chinese, no problem. Okay. So it's chapter 1 to chapter 9. Okay, including many things. So introduction, property use in many other special ML parts by the mixing, ML process. Okay. This one is very good. I spent a lot of time to translations. So a lot of people tell this one what is mean. So here. So somebody will say, Dr. Q, the metal injection molding is same as the metal powder injection molding. I said it's the same. But if you just only say metal injection molding, most of people are thinking about, hey, Dr. Q, the metal melting point is very high. What kind of injection machine can melting metal then to injection? So if we just metal powder injection, I think it's much good. So we don't about the mortality. So for example, you just watch the metal parts, like here, MRE parts. What's the second about? It's a 3D dimension. Yes, it's 3D dimension, and it's very complex, not easy. Yeah, the shape is very complex. Yeah, difficult to machining, difficult to get. So you need to mold. Spend the time in the mold, then injection duplicate very quickly. Am I right? Yeah. If you want to do one piece, just one piece, what kind of process do you want to do? Just only machine. Yeah, use the machine. Very difficult. Just only one piece. So if now we can use the 3D printing. Alright? So metal 3D printing can make this one very close. Then we just use the machining to check everywhere. Machining and got 1 piece to 10 pieces to 1,000 pieces. If you have 10,000 pieces in one day, what kind of process you can do? Just one judgment. So that's why the injection molding, the expense is tooling. Tooling is very expensive, and then you need to spend time to do the tooling. Then after the tooling finish, you get the injection very quickly. This is one reason. The first, MI like plastic molding in the mold. Okay, the mold almost the same, but we just adjustment some place for the Facebook easy flow. Okay, so first one, MI is like the plastic process, no problem, no issues. We just use the same injection machine. We just a little change in the bevel and the screw because the Facebook, metal Facebook is a metal with plastic, but plastic only plastic, so the material is different. Which one easy to cool it down? Am I more plastic? Do you have burn plastic material? When you burn, it will melt and very hot, and it will cool it down a lot of the time because its thermal conductivity is not good. Then, if we add the metal powder inside, the plastic only 10% weight. Then we burn is mounting, but the cooling down is quicker. Why? Because the thermal conductivity within the metal powder is higher and easy go up. So this part is easy cooling down. So it's very interesting. It's different too. So this one can control our green part strength. When we bring down the span, time should be short because we will cycle in the quicker. Am I right? Because one time we just a quotation for customer. Okay, this one in the future is buyer. We just say, I buy your MI part. How many cycle time? We just count counter your cost. Okay, we just say. Oh, 30 seconds, one shot. One shot is 4 kg. Yeah, but this guy is hey, come on, boss. I just spent about 18 seconds can make one shot. You just say, shh, don't tell buyer. We just say, oh, we need to spend about 30 minutes. Why? Because you can earn more money in 12 seconds. Understand why? Because this is you save the time, we can make more. We make the quotations depend on the cycle time. Okay? Cycle time more, the cost will be high. But in fact, we can change the cycle time, but depend on what? Depend on the quality should be high, should be good. So we need a lot of quality control in the MM process. Not only MM process, every mechanical process, every process should be controlled to see quality control. So in the future, you go to the job, quality control. Now, what is your quality control? Professional team, you want to make a quality control. You just give you the explanation. You write down the answer, you make a quality control. And you confirm everyone can understand Dr. Hugh said what Dr. Hugh said. Then, in the future, you just say, okay, Dr. Hugh just touch me something like the information rate, like the continuous rate, like the something. So it's very important. So I hope I give you some direction, then you can help me to understand this one. Okay. Oh, okay. So the MM part should be is huge. The first, what is huge? It means one batch need over 10,000 pieces. It's much better. because this process wasting a very expensive tooling. So this is the first concept. And the tooling cost like the plastic is second. Okay. So quantity and the tooling cost is 2 is plastic. Okay. This is a traditional PN, use the powder, go inside and pressing. Pressing and the sintering is easier. Yeah? Am I right? Yeah. But the shape is easy. It's just only 2D. Why? Because this direction is tooling direction. You cannot make the hole inside in the sideway in different side. Okay. So this one is normal. But if you want to side hole, we just can use the plastic concept. Use the melting materials and the materials will form in the side hole. So this is fine. So this is traditional powder. Here, this is here. Okay, this is MM process flow. We just use the powder and binder ourselves. Okay, this is a process flow. Okay, the first we just use the powder. Powder depends on your choice. For stainless, for tungsten, for copper, for titanium. Just a moment, professional team just asked me, should we do the titanium powder? I said yes, but sintering is difficult. Yeah, but injection molding is easy. We can do the adapted material. It uses the same mold. Why? Because this is the same as plastic. We just make a different feedstock, different material feedstock. For example, the titanium, for example, the stainless, for example, the iron, for example, the copper, for example, the nickel, for example, is stainless steel something. If we just got a powder, if you follow, every powder is less than 13 microns. Right now, MM powder should be used less than 13 microns. Okay, 13 microns. 13 micron is a limitation. Why? Because if the powder is bigger, the sintering rule cannot follow the Archimedes principle. The density is mass and volume is different. So the shrinkage is no good. But the powder is less than 30 micron. The rule is true. Okay. Okay, so we got this one missing in the machine, and we got the physical pellet. Okay, it's an English saying, granulation and pelletization set. Okay, and then we got the feedstock. Then we use the feedstock like a plastic pellet and go into the machine. This one is paper, hopper. And put on the hopper and use the screw to push down. Okay. So, hi everyone. Today is the first the watch injection molding. Which one? Who? Injection machine. 第一次看到射出机的举手。Okay. So now you understand the injection machine. Okay. So a lot of parts, for example, your mouse. Your notebook housing, your cell phone, some plastic parts, always by molding. Okay, so in mechanical department, the tooling and the molding is very important for us. Make this one, we can do parts, and we can do the duplicate and repeat the parts. Every part is the same. Then we can get the low cost solution. Okay, so use the mold, use the tooling. We can do many same work in the parts. Okay. Okay, then we got this one, we go to the debining. Debining is to remove the binder from parts. Then go to the center, you will consolidate it. Okay, this is the easy process. I think the team will make this one for you. What is the MIM process? Please join down. Okay. Professional team like everybody join with some text. He don't like only text. Okay. So please join down. Join down is very important for your engineering training. Everybody is learning how to become a good engineer in the future. So the drawing is very important. Okay, drawing and some text explanation is very important. So somebody say, Dr. Q, my drawing is very ugly. No problem. Ugly is ugly, but you can write down something. You can save the time because something needed to. If you use just only the language to speak, you need to spend a lot of time. But remember, how to improve your English? How to improve? Before I in NTIT, Pauline just said, "Hey, Dr. Q, you are the best student. Your English is bad, so bad. This is your life, the poor and fail things." It just pushed me. So I just thinking about how to press my English. Okay, just a translation English into the Chinese. Then I just do everything, translation English to Chinese. So if we want to practice Chinese, please translation to understand. Okay, because now computer is very easy to use. Okay, save your play game time and read English. Okay? Okay? Play the game. Since you play the game, you are king. But spend about 1 hour every day, 1 hour to learn English. Now you spend 1 hour. In the future, you will learn more, go back, even the 1 hour. Believe me, every month I write down 1 paper for magazine in Chinese, and 1 season I will write down a paper, English paper for PIM International. You can check. PIM International. Okay, it's an English magazine. You just check Dr. Q. Also, it's YHQ. From 1917, every year I write down one or two papers for explaining the economic status of China, economic status of new development way. MIM compared with mental AM, additive measure, and 3D printing within our mental power. Every year, I just write down a development paper in the website, so you can check it. Including the English website, including the Chinese website, you can also watch my paper. Yeah. Spend time. Every time you write down the paper, then you read, you modify, you will remember many things. It's very important for student study. You want to study hard, you want to study high evaluation, write down and read. Read it by yourself. Then multiply by yourself again, and you can get a very good upgrade. Okay? So please, everyone, learn Chinese, learn English. It's changing. Yeah. Then remember, this one is the best. In the future, maybe equal to Apple. Equal to will become the big boss. If you can get the Apple order, your boss will give you more money. So this one is guy, maybe he is a good guy in the future. Okay? Am I right? Am I right? Yeah, because in the airport, I go to airport, the casino, Chinese, Asian people, Indonesian people, Indian people, so many, everybody inside. And which one is better? Depending on the result. So everything is push. Every day is just overtime. Nobody will tell you overtime is a problem. No. But you overtime, you got a good result, you upgrade your position, the money will be higher. Maybe you can jump into maybe you jump into heaven and do certain things. So please, when you are student stage, please study hard. Game, in the future you can play the game. But you will lost time in student time. It's never repeat. Okay? So I push my students. You are my kids. You are my junior classmate. I hope that you can follow me. Yeah, spend time. You now spend 1 minute in the future. You can learn 1 minute more. Okay? Okay. So we just call materials. The powder. How much? How much?
30.
Okay, so 30 micron is 0.03 millimeter. Okay, so how many diameter of your hair? Do you have check? Have been check? No. Boy, maybe it's 100 to 150. Girl, maybe it's less than 100. No, so this means the powder size is very small, like similar to your hair, the dimensions. So remember, this is we just call this one as ball size. Like a ball. But how do you count the powder? How do you count? We use a special way. We use a laser to count this much. Okay. Before, not easy to count. So, Tim will explain this question. How many pieces powder in 1 gram, 316 10 microns? You can count. Yes, remember? We can count. Because the 1 gram is the density is 316 L. The density is 7.9. Come on. Yeah, so we can calculate 1 gram is how many powder. Then 1 piece is 10 micron. So what's the order? This is we can cut that order. Yeah. Then this one is micron. We can exchange to cubic centimeter. Okay. Then I just tell you it's 0.02 3 billion pieces. My God! So in this one about 3 grams. This means 1 billion piece powder inside. It's true. So I can calculate this one by this one, then we know how many pieces in 1 gram. So this one is a huge numbers. But huge numbers, why they can control by your process? Why? Because we understand the principle. Just only mathematics and physical equation. Okay? So everything we need to send simple, then make it 0 and 1. Am I right? The computer is 0 and 1. Yeah? But we assemble this one, we can do everything. We can make it a Web3, we can do the game, we can do something. So everything digital nation can make a computer to calculation, can use the AI. Yeah, in basically, we need to understand the principle. Easier, non-competitive. Okay, so we just need this cubic. We just need a cubic is enough. Okay, so not very difficult. No weighty calculus. No calculus. No, we need this one. Just only this one. Okay, so just only simple mathematics. But you need to understand how to make the calculation. Okay, so this is the fundamental of the powder. So we need the powder, know the powder. Okay, so okay, now we discussion the powder. Okay, what the properties, what the features of the one powder? So what is powder shape? Powder shape. Yeah. Which pen is better? For MI? Right. Oh, here. This L is one. Which one is better for MI? This one? Why? You think in crystal as a 1,000,000,000 piece powder, if everybody like this one, is it easy to flow or not? So which one is better? This one better. Is it right? Yeah, but this one, you need to make it like ball. You need to spend more money. And the problem is a ball easy control the flow rate. Easy or not? No. When you make it everyone 1,000,000,000 piece, it's always like ball. It's a rotation will be friction. Friction will become heat. Your binder will be blowing, so you should be control these ones. So our experience before 20 years before, everybody is thinking about this one. Everybody don't use this one, but we have a newest processes. We make this one powder just a little, but the powder is like this one. like what? Potato. Okay. Okay. Interesting here. This powder is it's more cheaper to do. Like this powder is not very cheaper, but the shape is not good. So we don't like this one. But this one we can do very quick. When injection every piece, the powder will be changing the direction. And then finally, we find this kind of powder can make a higher density more than this one. Interesting. Why? Just like the rice. Do you buy rice in your country? Rice. Rice. Then you buy the rice and use the cutler and cook the rice and put more. Why? Because the density become high. When you tap this one, this powder will be jump up and jump down, and the force later every piece rice will straight. So they can arrangement closing very well. So we use this concept to the NIM process, and then finally find the powder shape is like a potato, can get the good density. So you can do thinking about. If you want to use a ball or use a potato. And finally, this one is much cheaper. This one is very expensive. Yeah, it's very interesting. So now in China, this kind of powder is about, for example, 316 ml. It's 1 kilo. You know RMB? RMB? 知道人民币吗 ？RMB? What kind of rate of RMB and NT dollars? 4点。
350块。
Okay, that's what it is. So I don't know how to exchange the Indonesian cost, Indonesian dollars. 500. So you can understand. So this one now is about 80 RMB 1 kilo. But this one about 1 kilo is about 60 RMB. Okay. So it's 25% cost growth. Okay. So understand. So that's why we need to basic principle to understand this one. So not really the whole is good. Maybe this one depend on our recipe. So the first part, when we discussing the powder, the first line is the shape. Okay. Shape. Geometry. The second is the surface condition. Yeah, if the surface condition is not good, like this one, then we find it interesting. If the surface is smooth, it's good for molding, but easy to segregation, binder and powder. If we use this one is no good surface, but binder can easy to catch. So this is interesting. So we choose this one. We just adjust the recipe of the binder. We can make a good flowability, viscosity, better than close this one. Yeah, because the ball, the surface is too small, smooth, cannot catch by binder. It is separate. So when you after molding, for example, you mold it, you will get here this way, and the other side, the density will lower because the powder cannot be able to go. Binder just go and go more, powders go less. So the density, this side is more higher, this side is lower. This is the problem. So we needed to control everything like this one. So we needed to understand the powder size. Powder shape and the surface condition. Okay, so it's 3S. So powder has 3S. You need to understand shape, size, and surface condition. Okay, so this depends on you understand, but it's easy. Okay. Okay, today I think it's finished here. Everybody has a question? Any question for me? Please. Wait a moment. Next time, if I ask you, please answer is my name is blah blah blah. Because I cannot remember everybody. So if I say my name is from Indonesia, my question is okay. This is for international classes. Everybody can use English. If you go to Japan, if you go to some Chinese school like Nanfang科技大学, South of Science and Technology, you also use English to explain English language. Everybody talking about English. Maybe in the future, everybody talking about Chinese. But English is more important. Yeah, because every computer and something, numbers in English is command or something. Okay, please. Yeah.
My question is, we know that relatively additive manufacturing is premise sometimes.
Yeah.
So we know that, like you say, you have like it's molding for the assignment of I understand that this molding offer mass production.
Yes.
There's a recurring benefit. So, for your perspective, we don't know like that manufacturing is still growing. That it's possible like manufacturing offer like the purpose of material like the customization. So it is possible for manufacturing to like compete to the molding, or it has different market.
Yeah.
And the second question is, what is another advantage besides the mass production organization?
好，来考试一下，你听懂他的问题没？Do you understand? The half and half. No problem. Just a little difficult because this is a big question for me also. Yeah, he asking me why you choose because I'm doing so my nature is live. So I just say, oh, this is something. But if I change my position is to digesting, I will say, oh, that digesting is very good or something. But very interesting is if we list comparison, everything should be confirmed. Okay, so I give you a drawing. Just one. I give you a drawing, okay, and you can understand more. one. Oh, this is including the answer too. Okay. Here is a metal process. The first one is a liquid metal technology. And this tool is forging. Okay. Today you know the plastic forging, just hammer the steel. Okay. Then you know the low swartz casting. Somebody know the low swartz casting? Yeah, we make the wax mold, then use the sand in outside. Then to melting the wax, we leave the sand cavity, then input the metal. So this one is a low wax casting. All in English, investment casting. Okay, it's melting the wax mold and get the cavity, then input the metal water. Okay, so the other one is a PM, pressure molding, and it's 3D printing. This is a MIM. So we compare the A features. The first one is features. Okay, which one is much better for density? The other is for density because the layer is outside square, the inside square. But we just know discussion the defect. We just with this talking about service problems. There's a discussion of machine cost. We list the freedom of the design. Then we check the mechanical property. We check the manufacturing ability. Okay, this one is difficult to mention. We just use the cycle time. If we use the cycle time, the MI is very quick. Yeah. For example, the 3D printing, we just need 70 hours, maybe gather one piece. Okay, 10 pieces, okay, 1,000 pieces. But you compare this with me. Okay, one day at least we can make 2,000 shots. If you have a 4 cavity, so 2,000 shots plus 4, you can get about 8,000 pieces. It's very big. So this one is good. Okay, who can compare to me? PM. PM is PM is 1 cavity, but its cycle time is only about 3 seconds. Very quickly. So difference. Okay, but the others, I think this one is loss waste and fortune something is lower. Okay, and accumulation. Okay, we just compare this one and this one is a freedom of materials. Freedom of the material, what does this mean? It's if you want to change the materials, use the same tooling, use the same equipment. It's easy or not? The MIF is easy. The others, I think, cannot because another easy to do. So we can compare this one. So this one is an answer for your question. We make the detailed comparison and spend about 20 years. We find the MIM, the total amount of the sales goes up, goes up, goes up, goes up. But just small comparison with casting, comparison with the others, because the others is transitional, it's already a big market, but we just a little catch. Then we continue together up and up and up. Okay, so this depends on what kind of position you will stay. Okay, when you are buyer, you want to buy a part, you will choose what's your concern. The first time you need the dimension correct, and you need the useful, and you need the hardness should be higher, and you need the fatigue should be good, and the wear resistance should be higher, and the corrosion issue should be less. So comparison you have conditions, then you make a decision. So in engineering training, everybody now is pre-engineering because you are student. When you get the graduation, you get this paper, then you go outside and go here. This is your also is a senior classmate. Okay, he's already the engineer so many times. And Mr. J, he is a sales engineer. You needed to sell the parts, and the customer just say, hey, Mr. J, can you please check my drawing and do something for me? I will pay you money. He's a happy owner. The person is happy, but when you cannot deliver, sorry, you will cry. And one thing is that when you deliver, the customer no money for you, you will cry. So the sales is not easy to do. And you need to drink more beer, you need to play everything, company with the customer. Then if the order cannot become money and delivered to your home or your boss. This is very difficult. So everybody now is training. Training everything, then we choose which one. Which one you are professional? Please remember, you are from NTIT. You have a mark here. NTUST. Okay, you are Superman. You need to meet so many difficult things and make a solution by yourself. Cooperation by your classmate. I am your backup. Team is your backup also. So please, everybody, remember this time. Today is my first class, not the final class. If you're lucky, you will meet me anywhere. Okay. So if you want to miss me, just write down my name. Check my website. I'm there. So everything, please. Today I'm very happy. After 32 years, I go back here. Okay. My lab just only the second floor. Okay. I stayed there about 5 years. Master degree to PhD degree. 1 year, 4 to 5 years. So I think this chance is very good. Thank you, Professor team, give me a chance. Okay, so please, everybody, learn this one, and you have better gift. Every time say, you make this one, modify your next, you will remember Dr. Q is not you. Okay, and you will the best pickup.
Yeah, I have some question. I'm from the student in Taiwan. Yeah, I'm Injay. My question is that how to control the particle about the same size?
Yeah.
Because I think the porosity will be an important parameter that it will be. Yeah.
And so we need to do some action. Some actions. Next class is I will introduction for control particle. The easy thinking is to use a mesh. Use the mesh. Different mesh we can make mesh. The range. We just need a range, control range. But mechanical mesh is not so good. Why? Because when the powder is very small, it will fly. So we can use an air mesh, airflow mesh. So airflow mesh in the industry is very popular. Depending on your mesh, there is a mesh frame. The mesh frame speed very quickly. The powder go out is very small. It's very slow, the go out is big, depending on the airflow. So the mesh is the best solution. But we have a mechanical mesh and the air mesh, two-way. So we can control the range. Okay. Sometimes we need to make a mesh separate about 1, 2, 3, 4. Then after we separate 4 batch, then we just choose which batch mixing together again. Why? Because we need the control. For example, MIM, we need less than 30 microns. But also we will choose about just 1% to 2% boron percent. Added 5 powder. This one is about 1 to 3 microns. Very small voltage, but the quantity is super huge. Okay, we mix it again, separate, then we can cut it good. Because when we injection molding, after finally we will use high pressure we say this one is a keeping pressure. Why is high pressure? Because we need to keeping the shape. It's uniform, no shrinkage. So we use high pressure. Push materials. Then materials will cooling down. The shape will duplicate the tooling cavity. It's very well. Then no shrinkage. So when we push the feedstock, the liquid feedstock, the fine powder will go outside in the cavity surface. So the surface should be more beautiful, more fine powder, more beautiful, more high density. This is an MIM process technology. Okay.
Okay.
So next class we can check how to control the powder and how to make a 3x shape, size, shape, and service condition. Okay. Okay. Thank you everybody. Okay. This one is constant. This one is small, very weight. Weight is high. You can compare this again. Okay. This is constant. Use for vibrate for your watch, Apple Watch. This one will vibrate. Then you can bring it up. Yeah. Because this one is small, so we use the constant. So this is two different. Okay. Sorry. Yeah. This called whole table. Okay, different.